All right, we're getting into triangle proportionality. Yes, all about proportions. I'm going to recommend you pause and go find yourself a couple colors, either colored pencils, colored pens, or colored markers, like thin markers. It is really, really going to help you with this first part when drawing the diagrams, okay, because you can do these proportions a couple different ways. So please pause, and I would recommend colored pen or colored skinny marker. That way it's not too much going on over here. The colored pencils may be too thick, okay? All right, so I'm going to use two different colors to represent some things here. I know my purple, or one of these is dying. Let me find my colors here. All right. We're going to take a look at these proportions. With your triangle proportionality theorem, what's happening is you are using indirect measurement to figure out a missing part. Okay, a lot of this deals with, hey, so this guy's 5 feet tall and his shadow's 8 feet long. If this building's 50 feet tall, how long's its shadow? That's what these proportions do. With a triangle proportionality, you see all these little bits. You're seeing this triangle inside of a triangle again, like we did with similar triangles. One thing you need to understand is your triangle proportionality, these have to be parallel. Okay? They have to be parallel. That's the big rule. When we're taking a look at this, let's start looking at these proportions. We're finding this missing piece right here in our proportion. So we take a look at RW. RW is right here. This is where one of my colors comes in, okay? It is going to be proportional to WS. Same color, WS. I want you to see the two parts, okay? They're doing a ratio of this section to the other section of the side, all right? Next, they're going to look at, over here, we've got RL, same color, RL, to, well, which part's missing here? Right here at LT. Okay, so LT would go right here. This is one way you can set up a proportion, and we'll see this in the examples. This is my favorite way to do it. It's the easiest in my opinion. Let's take a look at the other one. So I'm going to grab my other color, and we're going to take a look at what this proportion says. RW, okay, so same thing right here. But now they're looking at RS, the entire thing. See why we want two different colors? Right? So part to the whole. This is part to part. Now we're looking at part to whole. So then here we're looking at, okay, blank to RT, which is the whole. Well, which part did they use over here? They used basically the smaller triangle. Okay, so we need to use that same part right here. So we'd be using RL. And we start working on these, it'll help you out a little bit more, okay? Now, you may use the bottom part to the whole. You might use little part, or one part to the whole, or you might use the other part. It all depends on what information is given. We'll go through plenty of examples. So let's do this again with our colors, okay? TA, right here, is to AR. Can't draw these backwards, sorry. Can't draw them backwards. There we go. AR. So TI is to, so this is the part to part. And we did go AR, so we want to go IO. Yeah, you did it backwards on that one. All right, now let's look at the part to whole. We have TA to TR, part to whole. Now we want part to whole again. Well, we want the part on the top. Which part they use? They use the part over here on the right. So we're going to use this part on the right, remembering that it said T to A, so we need T to I. Is going to be to TO. So part to whole. So TI. Now when we get down to the nitty-gritty of it, when we get down to these problems, a lot of these, the proportion is literally staring you in the face. And what I mean by that is take a look at number 5. Literally right there. This is how you set up your proportion. Fraction bar equals fraction bar. 8 over 6 is equal to x over 15. 8 over 6, x over 15. I love these things. They're amazing. Okay? You should know how to do our proportions. I want you to pause it, okay? If you'd like to, you can also simplify this 8 over 6. I like to show both ways a lot of times. Okay, so actually I'll do this first. Well, no, I'm gonna let you guys do this one on your own. Please pause it. The answer is about to pop up. I'll give you a second to grab your mouse and pause the video, work it out, and check your answer. All right, now that we're done working it out, we should have gotten magic number of 20. Okay, if not, check your answers. Cross multiply 6 times x, got 6x. 8 times 15, we get 120. Divide. Cross multiply, divide. All right, so the next one, we're going to have to do a little extra before we set up our proportion. What we need to see here is that 30 is the entire side. We're not, please, because we have this over here, you can add this and do part to whole, just do part to part, okay? All we need to do is this 30 minus the 9 that's down here, with the whole thing's 30, take the 9 away, we're going to end up with 21 left over. So we're going to ignore that 30 now. And so now we have fraction bar equals fraction bar. X plus 6 over x is equal to 21 over 9. You can simplify if you'd like. I'm going to go ahead and simplify this 21 over 9 to show you this. You don't have to. Okay, you just got to deal with bigger numbers. But I know for a fact that 3 is going to go into both of these. And if I divide both of these by 3, I'm going to wind up with 7 over 3. So now I can do 7 over 3 instead of 21 over 9. Because we do have distribution, I will quickly walk through this one with you, but when we have it in a little bit, I'm going to ask you to solve it on your own. We're going to cross multiply here. I'm going to get 3 parentheses, x plus 6 is equal to, cross multiply the other side, we get 7x. Again, if you did not simplify, you'll get something different. Here, distribute, 3x. 3 times the positive 6, we're going to get plus 18 is equal to 7x. Subtract that 3x. I like to move that smaller guy. Okay? Don't forget to carry that x with you. 18 is going to be equal to 4x. We divide both sides by 4. Yes, we will get a decimal. X is going to end up being equal to 4.5. Okay? The next one, I'm going to encourage you to pause and try on your own. It's a lot like what we just did, but you're only going to have an x on one side. You're just going to have some distribution. But you're also not going to have to figure out any of the parts. We're going to do part to part. So here you go. There's your proportional setup. I encourage you to do it on your own. So here when we set this up, we're going to have 6 over 4 is equal to 2 plus x. And I'm going to rewrite this, guys, because I like my x first. I know a lot of students who like that. X plus 2. I'm just going to rearrange these. Over 5. Okay? I'm going to pause it. If you'd like to simplify 6 over 4, I will be doing that. Please pause it and solve it from here. Okay? It's going to be a little bit easier than number 6. Please pause it. The answer is about to pop up. Are you freaking out because you got a decimal again? Guys, we get decimals. Okay? We should have gotten 5.5. If not, check the work. Check your distribution especially. Make sure you distribute it to the 2. It's the biggest mistake that is made. Again, number 8 is going to be almost exactly like number 6. Almost exactly, just different numbers. Every other thing is going to be exactly the same except for the numbers. Please pause it and try this on your own. The setting up everything. Please, please, please. Okay? If you're needing to see it walked through again, no big deal. We're going to do part to part. So here I need to figure out what this upper part is. So we're going to take that 42 and we're going to subtract the 16. We're going to find out this side is 26. So that 42 is gone now. Your proportion, fraction bar equals fraction bar. You have x plus 5 over x is equal to 26 over 16. Simplify it if you would like to. You do not have to if you do not want to. I said I was going to on the other one, didn't. I'm going to go ahead and simplify this out. And I'm going to wind up with 13 over 8. Let me move it this way. So now the 26 over 16 is gone. All right? So whether you simplify or not, please, again, you need to challenge yourself. You need to test yourself and check for your own understanding. Do you get this? Okay? Please pause the video now. I need you to push pause. The answer is going to come up. You need to try this on your own, please. Or we should have gotten a whole number on this one, finally. All right, we should have gotten 8. If we did not, please pause it. Take a look at what I did. Okay, check out what happened and where your mistake was with solving for X. All right, last side here. And I am going to let you know at the very, very end of this, the print was printed too big, and we're going to have to write really, really tiny down here at the bottom. I'm just giving you a forewarning. We're going to have to do 4 different proportions down here. Okay, so get another sheet of paper. Okay, so I was talking to you guys earlier about what's called indirect measurement. Okay, that's what's going to go right here in this first blank. Indirect measurement. This involves using properties of similar triangles to measure heights, lengths, or distances that are too big to actually get a ruler and measure it yourself. I gave the example earlier about like a dude standing with a height and then, you know, a big old tall tower and a shadow, and its shadow. You're actually going to see that one here. That's one of the most well-known indirect measurement problems, and we use proportions. We also have scale factors, the scales of maps and stuff. So right here, what we're going to take a look at is we are going to look at the scale map of a downtown Dallas is 1.5 centimeters to 300 meters. If the distance between Union Station and Dallas Public Library is 6 centimeters on that map, then what is the actual distance? So what we need to do first is determine what are the units for our ratio. Well, we need to see here that this right here, the 1.5 centimeters to 300 meters, you see that colon? That's telling you we got a ratio. So this is going to be our ratio. And so our units are that centimeters to meters. Okay? So the second thing we do is draw a picture if we need to. Okay? In this case, I don't see us needing to draw a picture. All right? We just need to put the numbers where they go. Centimeters are going to go on top, meters are going to go on bottom. So the first proportion here, our third step, is we're going to use the ratio of 1.5 centimeters to 300 meters. Centimeters goes on top, our given 1.5, and then our meters of 300 go on bottom. Guys, this is converting. Like whenever you are in chemistry and you're talking about moles, converting, they have this procedure they have you do, but it's all about proportions. In the next problem, we're going to be converting from feet to inches and inches to feet, okay? Proportions. It's all it is. So we're going to go from centimeters to meters. So now we need to take a look at what did they give us. They gave us that the library is 6 centimeters. We want to know the actual distance. We need to remember the actual distance, okay, is going to be the meters. This is in real life. They gave us centimeters of 6. Centimeters was said to be on top. So we get to put the 6 on top. We are looking for the meters. That's our X. So use this proportion, cross multiply. We're going to shorten this video. Do it on your own. Please pause. This is a simple cross multiply, divide. It's all you need to do. Please pause the video now. All right, you should have cross multiplied, divide. You're going to get a big number, 1,200. Okay, 1,200 meters. Okay, so the next one. Let's start writing tiny. We have a flagpole that casts a shadow that is 50 feet long. So here's your flagpole. Here is your shadow. So let's go ahead and start, labeling some things here. Your flagpole right here, we have 50 feet long. The shadow is 50 feet long. So down here we have 50. Okay. Actually, let's wait on that one. Sorry about that. At the same time, we have this woman standing right here, and she has a shadow that's 5 feet 4 inches. And she is 5'4", and the shadow is nearly 40 inches long. Look at all the inches in there. We don't want to deal with the decimal with these feet when the inches it doesn't come out pretty. We're going to convert everything to inches. Just make this the easiest possible. Okay? Let's start off with the woman. So I'm going to go way over here. I'm going to write as small as possible. So we're going to start off with the woman. Now she is 5 feet and 4 inches. What we're going to do is we are going to convert this 5 feet into inches and then add those additional. So we can put plus 4 inches. So just take here, we're going to have, and this is what we did up here. I call this the legend. What do you put on top? What do you put on bottom when you're converting? So here we're going to put, on all of these, we'll put feet on top and inches on bottom for all of our conversions, okay? So the feet, she is 5 feet. We don't know how many inches. We know like 4 additional, but what is 5 feet in inches? We don't know, okay? Well, we have 1 foot in 12 inches. So we can use that ratio. Usually I write it the other way around. 1 over 12 equals 5 over x. But let's figure out what this 5 feet in inches is. Okay? We're going to do our cross multiplication real quickly, guys. Real quick. We're going to find out that x is going to end up being 60 inches. Now remember, we have to add that 4 inches onto it. She's these 60 inches plus the 4 additional. 60 only accounts for 5 feet. So we need to add the 4 additional inches. And so she is going to end up being 64 inches tall. So over here in the diagram, I'm going to write 64 next to her height. Now her shadow is 40 inches long. Sweet. Don't have to convert. The shadow right here on the ground is 40. Now let's talk about this flagpole. The flagpole has a shadow that is 50 feet. Guys, feet. We want inches. So here, writing real small, we're going to go flagpole. We're going to go ahead and we're going to leave feet on top and inches on bottom, just like we did over here. I'll do the 1 foot is to 12 inches. Well, how many feet? Feet's on top. 50 feet. 2, we're trying to figure out how many inches that is. So let's go ahead and solve for that. Nice and simple. X times 1, we just get an x equals, and our 50 times the 12 is going to give us 600. So that means the shadow right here, the flagpole, is 600. Okay, everybody see that? 600. We want to know how tall is the flagpole to the nearest foot. Guys, we're in inches right now, remember, okay? So we are looking for this right here. All right, this is all conversion. Now let's actually look at figuring out what this height is. The proportion is staring at you, especially when you get to draw your own. Look at this as an L. Height and shadow. Height and shadow. Ladies and gentlemen, your proportion, fraction bar equals fraction bar. 64 over 40 is equal to x over 600. That's all we have to do there. Okay? So we have 64 over 40 is equal to x over 600. I want you to go ahead and pause and work this proportion out. The answer is about to pop up. Please pause it. All right. When we solve this out, we end up with a little bit bigger of a number, 960 inches. Notice I put an emphasis on this. We want feet, so we have to take one. All we're doing is practicing, guys. I mean, nobody cares, right? We're having fun with this. We're practicing. So we need to do one more conversion to figure out what we have in feet. So again, I'm just going to go ahead and write it over here. We're going to do feet to inches. We have 1 foot is 12 inches. Here, we're looking for feet. Okay, that's our x here. We're looking for feet. Inches is 960. One more proportion to do on your own for this video. Pause the video, ladies and gentlemen. Pause it, pause, 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 pause. Solve it. Check your answer. All right, I hope you did it like you're supposed to. You need to check yourself, make sure you've understanding what's going on. Your total and final answer is going to be, the flagpole is 80 feet tall. All right. Again, as always, ask your teacher for any questions, or you can search triangle proportionality theorem and indirect measurement on other YouTube videos if you need additional help.